Hey, welcome everyone. We are honored today to have two renowned number theorists with us, Professor George Andrews of Penn State University and Professor Bruce Berndt from the University of Illinois, Urbana-Champaign. Their names are synonymous with the study of the mathematics discovered and inspired by Ramanujan, one of the most fascinating figures in the history of mathematics, and whose works go on to surprise and inspire us. And Professor Andrews and Professor Berndt, they have devoted their lives to unlock and understand the mystery of Ramanujan's work. And together they have offered a monumental 5-volume series on Ramanujan's Lost Notebook. And great to have the both of you here today. And I want to start with a questions that many people probably would ask you guys. When you talk to especially non-mathematicians, maybe family members, friends, they ask you about, hey, what kind of math that you do? How would you tell them? And in particular, how would you describe your work on the mathematics of Ramanujan's to non-specialists? Now, the reason I asked is because I was thinking about, writing something to introduce you in that context. But I thought, you guys have been doing it for decades. So why don't you start with that? Who want to go first?
Go ahead, George.
All right. We'll go in alphabetical order by last names. Okay. So generally, it depends on the educational and sophistication of whom I'm talking to. So if I'm talking to somebody who really doesn't know much mathematics and doesn't know, I will probably talk about the theory of partitions and some of the facts connected with, say, the studying of the number of partitions. I will mention that it has wide applications to things from statistical physics to computer science and things like that, and I won't do too many examples. If I'm talking with somebody, say, who has reasonable mathematical knowledge, I would probably move on to talk about, say, the major problem that Hardy and Ramanujan solved in getting an exact formula for P of n. And obviously, when I talk to my daughter who has a master's degree in mathematics, I can actually describe some of the problems to her, even though she's not courant in the mathematics that I'm doing. So it all depends on whom I'm talking to.
Great. How about you, Bruce?
Well, the answer is similar to George's in that it all depends on whom I'm talking. But a couple things I might say. So I might talk to them about large numbers and our inability to factor them. Of course, I have to explain what that means. And so I emphasize that our inability to factor numbers really is responsible, at least in part, to the safety of their communications. So that gives them some idea that maybe what we do is important to them. And then if they're a little bit more sophisticated, I'll say something about primes. Define a prime and say there are an infinite number of these primes, and number theorists examined, roughly how many and how frequently they appear. And so, we're really interested in prime numbers, and they have lots of applications, but I usually don't go into these applications so much. And I also, like George, will talk about possibly theory of partitions and the divisibility of the partition function if my questioner is a little bit sophisticated with mathematics.
Do you guys talk about this in family unions?
Uh, no, my family is members are wise enough not to ask me these questions.
So, yes, I do, because my elder daughter has a master's degree in mathematics, and my son is a computer scientist or computer engineer. So I can talk about a variety of things. The vocal teacher daughter is perhaps a little left behind in such discussions, but basically, there's more I can talk about than with more distant relatives who have no real mathematical education at all.
That's good. And I noticed that today both of you are wearing the same ties, right?
Exactly right.
Right, right.
What else could we wear?
The shirt is different color. Okay, the shirt is different color. Want to say about a little bit the origin of these ties?
Okay, so basically, my son manufactured this for me for a Christmas present one year. And just before Bruce's 80th birthday, I wanted to give Bruce something on at his 80th birthday conference. And so Bruce is one of the few other mathematicians who wears ties. And so this was an obvious thing to give him, which I gave him right at the beginning of my talk that kicked off the conference honoring his 80th birthday.
So it sounds like there are only two of them in the world, just two of them.
So I have some more in reserve for people as they reach landmarks in life. But at the moment, these are the only two that are that anybody owns and wears.
I actually have a stain on my tie, and my wife Helen wanted me to get this cleaned before the interview here, but I tried to convince her that, maybe it wouldn't get cleaned in time, so I'm here with a stain on my tie. Okay. But I will get it cleaned, George, sometime.
Actually, when I gave you that tie, I had a stain on my tie, but I kept my coat buttoned so that it didn't show. But your tie was pristine.
I can't tell there's stain, so wonderful, wonderful. That's a story of the tides. Okay. Now, if you could go back in time and speak to your younger self at the time around when you decided to pursue mathematics, so I suppose you can go back to do that. What advice would you give to your younger self, knowing that you would have devoted your adulthood in the work of Ramanujan's? What would you say to your younger self?
Well, keep doing this alphabetically.
So, my view of so many things is that things happen organically, and so I have on the wall of one of my studies a poster of Stephen Leacock, the Canadian humorist, and the aphorism on the poster is, "I'm a great believer in luck. I find the harder I work, the more I have of it." And I do think that there is a huge amount of luck involved in being a mathematician. And I do think that Stephen Leacock was right in saying that if you are working hard, the chances you have to stumble onto things and discover things that will really be of value is much higher if you're working hard than if you're not. So other than advice to work hard, I would basically leave the organic developments of life to whatever they are.
Yeah, you definitely works very hard, And how about you, Bruce?
Yes, I feel that, from where I'm at now, there really isn't any other path I could have taken. Often, people encourage young students by taking math contests and going to special classes. If I had done that, I would never get to this position now. So in other words, any deviation from the path I took, I wouldn't got here.
Why would that be if you were like trying out, math competitions, other things?
In other words, I entered college thinking I would major in physics, and after 1 year I went into mathematics. And, I didn't have any great background before that. I went to a country 2-room school. There were 5 grades in the one room and 4 grades in the other room. So I didn't have what is called a stellar mathematics education at all. And at that time I was mostly interested in sports. And, it just sort of happened that I had a great teacher in college who taught me almost all the courses. I was very fortunate to go to Wisconsin, where in my 3rd year I took a course in modular forms, which started me on a career in number theory. And then I was lucky to have a job at University of Illinois, where the head of the department, Paul Bateman, one day had me referee a couple papers written by Emil Grosswald on formulas from Ramanujan's notebooks. So all of this, this sort of path is not a usual path. And if there were other things that came into play, I wouldn't have got here today. Wouldn't have gotten here today.
And George, do you have mentors that shape your path, have been very significant in your journey?
The background for me is rather similar to Bruce. He had twice as many rooms in his grade school as I did. I was in a 1-room school. There were no electric lights in it until the 3rd grade, and there was a giant wood stove in the middle of the room to heat it during winter. I always had facility with mathematics. When I was a junior in high school, I had a choice of taking trigonometry or playing in the band, and I played the band.
Okay.
So, very similar to Bruce, I had a riveting, proselytizing calculus professor in college, and I started when I was a senior in high school. I went to the guidance counselor to talk over what I might do in life, and he told me there are no interesting jobs, but you're good in science and mathematics. And I had some interest in law. So he said, why not become a patent attorney so that you can make lots of money? Since you're going to be bored anyway, at least you'll have fun in your off hours. So I decided to follow that. So I started out in engineering at Oregon State, and I really enjoyed that up through the first year and a half. But then I got into the electrical engineering lab, and I never could make those circuits work out to confirm the experiment that I was supposed to do. And at the same time, there was this math professor who was talking about what a great thing it is to be a mathematician, etc.
Wow.
And so I turned my interest, I became a math major in my junior year, and I was going to study logic, symbolic logic, mathematical logic. And my parents ran into certain financial difficulties as I was approaching my senior year, so it was decided that I would finish my bachelor's degree in the summer of my junior year, and then in my senior year I would take a master's degree, and that way I would get supported. So so you had to write a master's thesis at Oregon State. So I went to one of the professors who had done mathematical logic and asked him if I could do mathematical logic. And he said he had no problems in mathematical logic, but if I was interested, if I wanted to do something in the geometry of numbers, he had some problems for me. And so that was the twist in the road. And So I then actually, my first two papers are in the geometry of numbers. I won a Fulbright scholarship or fellowship to Cambridge University in 1960-61. And during that year, since it was only a year that I would be in Cambridge, I was applying to various universities in the US. I'd hoped to go further into analytic number theory. So I was hoping to go to the University of Illinois, but Paul Bateman, whom I wanted to work with, was going to Penn for a year at the year for Hans Rademacher. So I wound up going to Penn so I could work with Bateman, but then I was in Rademacher's class and I thought this is fantastic. And so I decided not to apply to Illinois anymore, but to stay at Penn and to do my PhD with Rademacher. So that was the circuitous route that led me to where I am today.
Wow, that is quite not I was expecting, and Bruce, you in a previous interview you also mentioned when you were did I remember right when you were in college there were some financial situations too. What was that?
Okay. Yeah, since George mentioned the University of Illinois, let me indicate how I came to the University of Illinois. So in my fourth year at Wisconsin, I took a course in modular forms and applications to analytic number theory from Marvin Knopp. And when it came time to apply for jobs, he said, Bruce, you have to apply at the University of Illinois. I got my PhD under Paul Bateman there, and that's the place for you to go. Well, I had done my undergraduate work at a small college, Albion College in Michigan, and my goal was to go back to a small college and teach at a small college. I had no interest in large universities. Well, my first year out, I actually had a postdoc or a visiting position at the University of Glasgow. And I had interviewed at a couple of small colleges, but I really wasn't and I had offers from them, but I really wasn't happy with them going there. So I didn't really have a job after I left Glasgow. Well, in February of my year in Glasgow, I got a letter from Paul Bateman offering me a job. And I had completely forgotten that I had applied at the University of Illinois. So I didn't have any other place to go, so I thought I would come to the University of Illinois for just a couple years. And then I would just sort of get my feet on the ground, and I would go to a small college for the rest of my career. Well, I enjoyed it here very much, and I stayed for 52 years, and I still haven't gotten to a small college. But
okay.
I might mention that when I applied for graduate school, the University of Illinois rejected my application, but I got even with them, as you saw.
That's interesting. And George, I didn't really know that you start to think about switch to a math major when you were a junior. That's something that I would never imagine. Now we're talking about your path. This is just a hypothetical question. Now, if you have a chance to ask Ramanujan two questions, not three, just two, what would that be and why?
So when we celebrated his 100th anniversary of being elected to the Royal Society, the paper that I published in the proceedings of that event was how Ramanujan may have discovered the Mach theta functions. So the first question I would ask him is this at all close to how you actually discovered them? And the second question I would ask concerns a number of the identities for the Mach theta functions, as well as the asymptotics that he has for them, because I So Bruce and I have proved all these identities in these 5 volumes, but I do not believe that our proofs are how he, I don't know whether he had a proof or not. He may have. He may have had a way of seeing things which a more ordinary mathematician might sit with him and put together a proof. So I'm completely, I have no real thought about that, but I would, those are the questions I would really like to know the answers to.
How are you, Bruce?
Well, there's an unpublished manuscript of Ramanujan, just 2 pages long, published with the Lost Notebook, which gives 2 amazing identities, and these are involved with the Gauss circle problem and the Dirichlet divisor problem. These are 2 unsolved problems going back to the 19th century. They're extremely difficult, and they've been open. A lot of people have worked on them for many years. Well, I thought maybe these 2 identities, one connected with the circle problem and one with the divisor problem, might be useful in attacking these long unsolved problems. The identities are very difficult to prove, and I worked on these for a period of 6 or 7 years with my former student son Kim and my colleague Alexander Zarescu. And we did prove these, but I've never been able to determine, did Ramanujan, write these down because they were just beautiful formulas, or because they have an extra parameter in them? Did he have any ideas of, solving these 2 great problems? So that would be the first question I would ask. And then Ramanujan's notebooks are full of things involving theta functions. Theta functions are really the central theme of his notebooks. And including in the theory of theta functions are what are called modular equations. Well, for many of these modular equations, I use the theory of modular forms, which Ramanujan didn't know. So for most of this work, I gave proofs that certainly were out of Ramanujan's ballpark. And I still have no idea how to go about proving these wonderful modular equations using ideas that Ramanujan might have had. They've been a huge mystery for me, and occasionally I go back and look at these equations and ask, what did Ramanujan do to get these equations? I've never found out.
And then and in the third, volume of your notebook, Ramanujan notebook, that's where you discuss all these, very complicated modular equations, and I think, it comes to a point that both of you discuss about, that Ramanujan's insight, his intuition into mathematics. So I want to jump to that, for a moment. Both of you have spent, decades into, studying, understanding his work, Do you think, we are any closer to understanding his thought process? Maybe at least in some area, not the area you just mentioned, maybe in some particular of his area of his discovery, that we get a better idea of his mathematical intuitions, that insight, Any thought on that?
I don't think so. Like, every so often I've made a conjecture about how he thought about things. I just described the suggestion that I had some plausible explanation of how he discovered the Mach theta functions. I do remember at the 1987 conference at the University of Illinois, discussing things in the Lost Notebook, and I claimed that I believed that I understood how Ramanujan got 1 page of results on continued fractions, because there was a master formula on a totally unrelated page that would produce all of them if you knew enough. And so I thought, well, long last, I've certainly penetrated that. After my talk, K.G. Ramanathan came up to speak with me, and he said, well, that was all very interesting, but if you look in this early paper of Atlee Selberg, there really is, these are developed in a totally different way, and in some sense, a much more likely way than deducing them from the master formula that Ramanujan had. So I felt I'd sort of lost the ball there, and so I always use the word may have done this or may have done that, but I really don't think I have any real grasp of how he thought about things at all.
So Bruce, is that
Yeah, I agree. The amount that we know about Ramanujan's methods is very small, less than epsilon for every epsilon greater than 0.
Absolutely.
Occasionally results follow from one another. So, for example, in Ramanujan's notebooks, there are 2 chapters in hypergeometric functions. And this is followed by a chapter largely on continued fractions. So you can use hypergeometric functions to prove some of these formulas on continued fractions. So maybe this is how Ramanujan, thought, but it's just a guess. So the juxtaposition of results in the notebooks might give us some sort of clue. But.
I did once give a talk basically saying that it's worthwhile speculating about how he thought about things because it often causes you to come up with new ideas as long as you don't assume that you really are thinking Ramanujan's thoughts. It's a sort of useful game.
right? It's always helpful to kind of imagine how he would think about things and inspire us to find new paths. And now both of you have spent so many years in studying his work. Could you share with us your own eureka moment while researching on Ramanujan work?
So the huge eureka moment for me was sitting in the Trinity College library looking through an old box of papers of Watson and finding this 100-plus page manuscript, which had almost no words in it, and noticing that all of the Mach theta functions were in this manuscript, and not only were they there, but what was certain to be a disproof of a negative conjecture of G.N. Watson was there, so that it was clear that this was written in the last year of Ramanujan's life and that nobody had known about it until I started pouring through this document. So you can't beat that for a eureka moment.
We normally now associate with that the Lost Notebook, referring to that pile of papers and that and if I remember it correctly, originally that piles of notes were supposed to send to be burned before they were being rescued, right?
That's what J.M. Whitaker said in a letter to me, is that he visited the widow of J.N. Watson, and she was going to burn all these papers, but if there was anything of value, he could look through them and keep some out to deliver to the Trinity College Library. And this was one of the things that he saved. He saved also some other manuscripts that Bruce used very effectively in the first 5 volumes that Bruce did on the original notebooks.
Wow, that's amazing. That's amazing. That's amazing. What about you, Bruce? What's your eureka moment that you can?
I really did have a eureka moment. I had mentioned the 2 papers of Emil Grosswald that I had refereed and accepted for publication. And I hadn't thought anything more about this until my first sabbatical, which I took at the Institute for Advanced Study in Princeton. And one day in February 1974, I was working on transformation formulas for Eisenstein series, and I suddenly realized I could prove these formulas from Grosswald's paper by using my results. So it was a wonderful feeling that I could prove these results of Ramanujan using ideas that I had. So the Institute did not have a copy of the notebooks, but the Princeton University Library did. So I checked them out, found a few more formulas that I could prove, but a few thousand others that I couldn't prove. So when I went home, first thing I did was to write for a copy of the notebooks. They were published in 1957 by the Tata Institute. And it was a wonderful buy. For $25, including shipping, I got the notebooks in a wooden case.
That's a great buy.
Yeah.
That's a great buy.
So then I thought, well, just as a challenge for me, I would try to prove everything in chapter 14 of the second notebook, because this is the chapter in which Grosswald had proved the formulas and I had found further proofs. So I had no other ambitions. I just wanted to, as a challenge, prove everything in this chapter. There were 87 results altogether. And I had a lot of help from Ron Evans, who was my first PhD student. So then you might say a second eureka moment came when George told me that the efforts that G.N. Watson and B.M. Wilson made to edit the notebooks in the late 1920s and 1930s were preserved at Trinity College, Cambridge. So I thought, well, if I had a copy of these notes, maybe I could edit further chapters. So that's what started me on a 20 or so year period in which I worked on these notebooks. But I'd like to mention one thing, though. I never would reach the stage of your interviewing me if it weren't for my graduate students and postdoc. They helped me enormously in proving results from the notebooks and later also from the lost notebook. So I really owe my career to my students and my postdocs. They helped me enormously.
Right. So it's wonderful. Both of you, just found, just like discover a gold mine, and that you can go on to, dig into it, and that's just wonderful. Not only, in that aspect, but the both of you have such a long and fruitful, collaborations. You know each other for decades, and together you two work closely for over a decade to publish the 5 volumes of Ramanujan's Lost Notebook, and what is that the secret to such a incredibly successful and long-standing collaboration? Now, because, usually people, in professional world, people come together, work on a project or two, and then they part ways, but you two could, work together for such a long time, and produce these amazing results. What is your secret?
So the answer to that is it all relies on Bruce's brilliance, good nature, and good humor. That's what made the whole thing work.
Well, thank you for those remarks, George. I would say you were very easy and tolerant. I am a very fussy writer, and I can't read anything without interjecting improvements, at least what I think are improvements.
I was happy to be improved, so it worked perfectly.
So anyway, I'm grateful for you for allowing my fussiness in rewriting things. And also, I think I was the main one who organized the material. So you didn't complain about that at all. So generally, you didn't complain about anything I did. So that's one of the secrets, if not the main secret of our success.
Wow. Okay. So the secret is out. You two are able to work with each other. That's that's the key. That's the key. And in fact, back to Bruce, what you just said earlier a moment ago. In fact, both of you mentored so many students over the years and various stages of their careers. What advice would you give to some aspiring mathematicians who are drawn to the beauty and complexity of Ramanujan's work? How could they start, working in, this area?
So, my I so I've worked with I think I have well over 100 collaborators, and so many of them are most of them are decades younger than I am. So I would say that this field that Bruce and I work in is a field that is aesthetically appealing, intellectually challenging. It's just something great. So far as advice to any young person working in it, again, I go back to what I said earlier, that hard work, also being open to thinking about things in a new way, hearing what other problems and other things might come up. I know that when I was early in my career, I can remember in particular sort of making a discovery which several years after I made it, I published it in the Proceedings of the National Academy, but I sort of threw it aside because it didn't look like what I had hoped would come out. And it was only subsequently that I realized this is really a very interesting result, even though it isn't what I thought it was going to be. And so sort of keeping an open mind to things and that even in your own work, seeing what's going on is significant.
How are you, Bruce?
So at the meeting here at the University of Illinois celebrating the 100th anniversary of Ramanujan's birth, Freeman Dyson in his talk said that, if you're upset and you're worried and the things aren't going very well, just grab a copy of Ramanujan's collected papers from the shelf. And then your nervousness will, be ameliorated. And so I would now add the notebooks and the lost notebook. Just, take them off your shelf or maybe our books. And you'll see all these beautiful formulas. And so try to prove them. So that would be my main advice. And let me just add something to what George said about work. My parents were short of money for a number of years. They were farmers. And we had a few years in a row where we had late frost. And so the fruit did not come and the money did not come. And so my dad went to work at Whirlpool Corporation. So he really had two jobs, the farm and Whirlpool Corporation. He worked maybe 14, 15 hours a week. So the work ethic that I have received really came from my father. And as George says, it's a lot of hard work. When I was working on the notebooks and lost notebook, most people go back home after leaving campus and watch television. I went home and tried to prove things from the notebooks and lost notebook. So I'm not saying that everyone should not, people shouldn't watch television, but anyway, hard work is necessary.
In fact, that's one of the hallmark of both of your work. You spend years editing all these notebooks. Lost notebook is really a reflection of hard work, but pay close attention to details and open to new way of understanding things. And in fact, this brings us to the last part of these conversations, about legacy and the future. So, what do you think would be the most enduring legacy of Ramanujan's contribution to mathematics? What would be his most enduring legacy? George?
So look, I have great problem with linearly ordering things. I mean, he produced things that had have had revolutionary effects throughout the 20th century and into the 21st. So the collaboration on P of N with G.H. Hardy and the circle method is still vividly in use today and has solved countless a variety of problems in the more than a century since he was alive. Another collaboration with G.H. Hardy really is the foundation of probabilistic number theory. The various things related to modular forms, the Ramanujan tau conjecture, for example, had rippled through the 20th century and into the 21st. And certainly the things in the Lost Notebook have started really a huge amount of activity. All of these things have immense staying power, and I really can't point to one or another of them and say, well, this is the most important. They have tremendous. All of these things have tremendous implications, and I've probably forgotten several things that I should have mentioned.
Right. These discoveries were really ahead of its time, still, affecting, leading us, inspiring us to new way of thinking. And Bruce, what do you think Ramanujan's most enduring legacy?
I think George actually covered about everything. I'll just add a bit to the Hardy-Ramanujan circle method. In Ramanujan's notebooks, he has a lot of approximations and asymptotic formulas. So finding results of this type go back to his early days. So Ramanujan often used the words nearly and very nearly to determine what he thought were good approximations. So these beginning ideas involving approximation and asymptotics then carried over into the Hardy-Ramanujan circle method, the asymptotics of Mach theta functions. So this is finding good approximations and asymptotic formulas, that was central in Ramanujan's thinking. Yeah.
Well, looking into the future, what would you two say about the field of mathematics? How it will evolve in the next 20 years. What do you see are the challenges or the opportunity for mathematicians in the next 20 years? Not just in number theory, but in general.
So basically, as I said to you earlier, I regard myself as a very organic mathematician. I have very little belief in grand prophecies. I suppose that a counter to my statement would be something like Hilbert's problems that he announced at the International Congress around the turn of the 20th century, and that the impact that they have had. But for the most part, it seems to me that we can say, look at something like the Riemann hypothesis or something of that nature, or the twin primes problem or Goldbach's problem. There are things that have endured over time. Whether or not they will be solved, I have no idea. My main feeling is that I really am reluctant to predict the direction of mathematics at all. I do think that various things happen in the world, like AI, for example, that are going to have a significant impact, much as the various programs in computer algebra have had a significant impact, so that and say other scientific discoveries that will turn to mathematics for their assistance. What those discoveries will be and where things will go, I don't know. It is conceivable, as was a headline in Wired magazine a decade or two ago, that basically theory is out and data is in, and that people like Bruce and I will be out of a job in 50 years because the only statisticians will be of interest in any scientific endeavor. I must say that I doubt that, but of course, there are all sorts of possible ways things can go. And so all I would say is to any younger mathematician, keep your eyes open, work hard, watch for the developments that you might be able to contribute to.
Bruce.
The answer is I don't know. The only thing I would say is that I think there will be more incursions of mathematics into other fields, and this is about all I know. In regard to statistics, my younger daughter is an epidemiologist and uses a lot of statistics, so that's one area in which mathematics is going. I might mention that she has a few more publications than I do. She has over 50,000 citations, which we don't reach in mathematics.
Right?
Wow, that is so true. Wow, all sort of possible, development in the future, and this is wonderful. And thank you to both of you for sharing your time with us. Have this conversation, very insightful, very interesting conversation, and thank for your time. And we will see you next time in our interview series. Thank you. Have a good day.
All right. Good.
Thank you.
Thank you.
Thank you.
Both.